Hi learners, welcome to physics class today. In our topic today, we are going to take on electrical energy and power calculation. So moving ahead to the question, we have a question which says, in the diagram above, S and Y are resistances 10 ohms and 15 ohms respectively. If the power dissipated in X is 40 watts, then what is the power dissipated in Y? So to solve this question, we look at the diagrams, the diagram we have above. At the diagram above, we can see that the resistances or the resistors X and Y are connected in series. They are in series, so that shows that the same current passes through the two resistors. So the same current is expected to pass through the two resistors. So the current flowing through the circuit is constant. So I current is constant. Then taking the resistor X to be Rs, which is equal to 10 ohms, and resistor Y to be equal to Ry, which is equal to 15 ohms, and establishing that the power that is expected to be dissipated in X to be P sub X, which is 40 watts, and the power for that of Y to be P sub Y, which is what we are looking for. So making use of the relationship between power and resistance and current, we have that electric power is given by P equal to I square R. So with this, I square is constant. I square is expected to be constant in this relation. So in that case, P and R, that is the power, and the resistance is what is varying. So they are related in that way and they are varying. So in that case, we can say that P is proportional to R and that P is equal to KR, making K the subject. That means K is equal to PS over RS, which is equal to PY over RY. So using the established relationship between the powers of X and the powers of Y with that of their corresponding values of resistances, and substituting the values we have there, we can find what we are looking for. So we have that RS is 10 and RY is 15 and PS is 40. So making our substitution, say 40 over P, 40 over 10, 40 over 10 is equal to PY over 15, PY over 15, cross multiplying, we have 10 PY sub Y is equal to 40 times 15, which shows that P sub y is equal to 40 times 15 divided by 10. 10 cancels 10, 40 to give us 4, so we have P sub y to be equal to 4 times 15, which gives us 60 watts. So that's the value for the power dissipated in Y. So moving ahead, we have another problem which says in the diagram below, X and Y are 4 ohms and 6 ohms respectively. If power dissipated in X is 10 watts, what is the power dissipated in Y? Again, in this we have that X and Y are connected in parallel. So for parallel connection, we have what? Potential difference to be constant. For parallel connection of resistors, parallel connection of resistors, PD is constant. Therefore, using the relationship connecting power and resistance, we have that, and voltage, potential difference, we are going to have therefore that power is equal to V square over R. So in this case, the potential difference is constant. So you can see that we can establish that P is inversely proportional to R, so that P is equal to K over R. So making K the subject, we have that K is equal to Px Rs equal to Py Ry. So moving ahead, we have that P S R S is equal to Py Ry. So again, making Py the subject of the formula, we have Py, P sub y should be equal to Ps Rs over Ry. So making our substitution, Py is equal to, substituting the values, substituting our values, we have that the resistance through S is 4 and that of through Y is 6. So we have 4 times 10, 4 times 10 divided by 6, so that we are going to have that 2 cancels this to give us 3 and cancels 4 to give us 2, and we now have 20 divided by 3. P sub y is equal to 20 divided by 3, which will give us 6.67 or approximately 6.7 watts. Again, moving ahead, okay, P sub y then is 6.7. So moving ahead, we have a problem that says that from the diagram we should calculate the rate of energy consumption, and the next one that we should find the total heat energy developed in 15 minutes in the circuit shown above. So from the circuit shown above, we have that the current is equal to 2.5 amperes, and the overall resistance, the resistance or resistors are connected in parallel, so their overall value will be 4 times 4 over 4 plus 4. So that will be 4 times 4 divided by 8. 4 cancels itself 1 and 8 to give us 2, and 2 cancels itself 1 and 4 to give us 2. So we have 2 ohms as the effective value of the parallel connection of the resistors. So moving ahead, we are asked to find the rate of energy consumption. Rate of energy consumption is the same thing as the power dissipated in the circuit. So rate of energy consumption, therefore rate of energy consumption is same as power, electric power. So that means therefore that P is equal to, we are using resistance and current, so we are going to have P is equal to I square R. So making our substitution, we have I is equal to 2.5 square times R, which we found to be 2 units or 2 ohms. So we substitute it. So using calculator here, we have that 2.5 times 2.5 gives us 6.25 times 2. So that multiplied by 2 we have 12.5. So that gives us 12.5 watts. Yes. Moving ahead, the next question we are given is to find the total energy, heat energy developed in 15 minutes in the circuit shown above. So to solve that, again we have that we are looking for energy, that is W is equal to the power developed times the time taken. So that we make our substitution. W is equal to 12.5 times we are given 15 minutes, so in 15 minutes 15 times 60, we have to convert it to seconds, so we have to multiply by 60. So multiplying out, we have using our calculator 15.5 times 15 times 60 is equal to 11,250 joules, or we can leave it as 11.25 kilojoules. So that is the value of the second part of the equation. So moving ahead again, we are given a problem, a circuit, which we are asked to, in the diagram above, find the rate of the electric power dissipated in the 6 ohm and the 3 ohms resistors respectively. So again, to solve this, we have to say that the relationship between resistance and power is given by, with, for resistances connected in parallel, we know that they have constant potential difference. So we are going to use the potential difference version of energy or power to solve this problem. We are going to have P is equal to V square over R. So from here, V is constant, V square is constant, so we can go ahead and say that P is inversely proportional. P is inversely proportional to R, so that P is equal to K over R. So making K the subject, we can have that K is equal to P1 R1, which is actually equal to P2 R2, depending on the number of conditions we have. So with this, we are going to use it to solve the problem we need to find. So we're moving ahead. P1 R1 is equal to P2 R2, so that we make our substitution. We are looking for the ratio, the power dissipated in the 6 ohm and the 3 ohms resistor respectively. So that, okay, we have it in this way. That of 6 ohm is the first one, that is, this is one, so that of 6 ohm is the first one, so we can have it as P1 over P2 is equal to R1 over R2 over R1. Using a kind of cross multiplication here, we'll understand what I'm doing. So because if you cross multiply again, you still have what you have there back, that is P1 R1 will be equal to P2 R2. So that is the relationship between the two. So now say therefore that P1 over P2 is equal to, substituting the values, that is 3 over 6, and that will give us 1 over 2. Therefore P1 ratio P2 is equal to 1 ratio 2. Thank you for viewing. Thank you.